Hi, this video is about figuring out what kind of mathematical relationship your data represents. So I've got some made up data here and I've graphed it as well. And I want to know what kind of mathematical relationship it is. Now, if you look at the graph, it pretty obviously looks like it's directly proportional or linear. But there's another way of testing that. And sometimes it may not be as clear, especially if you try to put this into a calculator, into a linear regression and line of best fit. Sometimes it looks like this actually could be quadratic. It fits the data more succinctly and nicely than a linear fit. But the way that you truly test out and see which is the best is by looking at the numbers. So we need to pick any two data points and test for the relationship with those two. It helps if you do this with multiple sets of data points, not just one, but we can start with one and you see how it works. If it's a directly proportional relationship, that means the relationship between x and y is this: y equals some constant value times x. So if it's quadratic, then it's going to be y equals some constant times x squared. So the way that we determine if it's directly proportional or quadratic with two different data points is we find the ratio of y2 over y1 and compare that to x2 over x1. And if they're equal, then that means they've changed by the same proportion. So they go up by the same amount. But if it's quadratic, then we should find that the y2 over y1 is equal to x2 over x1 squared. So if you change the x value by a certain amount or factor or proportion, you have to square it in order to get that change in the y. So a change in the x is equal to a square of the change in the y. So let's do it. I'm going to pick these two data points. Let's say we go from 3.2 to 7.8 for our x values, and we go from 7.6 to 19.6 for our y values. All right, so let's find the ratio of the y values first. We'll take the bigger one divided by the smaller one, y2 over y1, 19.6 over 7.6, calculator says 2.6, okay? Then let's do the same thing for the x values, x2 over x1. I'm going to go backwards here, x2 over x1, 7.8 over 3.2, that gives us 2.4. 2.6, 2.4, those two numbers are very close together, and when you're doing your own data collection, there's going to be some percent error, there's going to be a little bit of margin of error there. So because these are so close, then we can pretty confidently say they've changed by the same factor. So they are both directly proportional. This one went up by a factor of 2.4. So this is times 2.4, and this one's times 2.6. And so that is a directly proportional relationship, which confirms what we thought with the graph. Let's look at another example. Got some new data here. Oops. Almost poked a hole in the wall. Okay. So we got our new data table over here, and I didn't graph this one because I just wanted to focus on this method here. Which relationship is this? So I picked two data points. I'm going to go from 2.2 to 7.5, and then the y values, I'm going to go from 4.4 to 51.0. So let's do the ratio of the y values first. So y2, 51, divided by 4.4, that gives us 11.6. So to test if it's directly proportional, then these two should also increase by 11.6 if it's the same or close to 11.6. So to test for that, we do x2 over x1, same data point, but now on x values, 7.5 over 2.2, that's 3.4. So 11.6, 3.4, not close, right? So that's not going to be a directly proportional relationship. So let's test and see if it's quadratic. So if quadratic, you do the same thing, but instead of the 3.4, you square the 3.4. So squaring the 3.4 gives us 11.56. If you look back at what the y values did, they went up by a factor of 11.6. So, in conclusion, as the x increases by a factor of 3.4, it does that right here, it goes times 3.4, the y increases by the square of that factor, by 11.6. And so we can conclude that this relationship is quadratic. That's all I've got for you in this one, so I will see you next time.